Hello, in this lecture we will answer on two questions. In the first question we find out the radius of this quarter circle, and in the second question we find out the size of this angle, angle theta, that is inside triangle ABC. So we start with the first question. In the drawing we have a quarter circle, line segment BC equals to 9 units, line segment CD equals to 16 units, line segment CD equals to 16 units, and line segment DL equals to 12 units. This angle, angle CBO equals to 90 degrees, this angle, angle BCD equals to 90 degrees, and this angle, angle CDL, it is also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. So here, first of all, because we know that this is a quarter circle, it means that point O must be the center of the quarter circle. I write it down. And this angle, angle AOF, must be equal to 90 degrees. And finally, line segment of side AO and also side OF, they are both the radii of the quarter circle, so we'll define the radius of the quarter circle as R. Therefore, OA equals to R, and OF, it is also must be equal to R. They are both the radii of the quarter circle. Okay, so here we will extend the straight line CD by a straight line until it intersects with line segment OF, that is the radius of the quarter circle, and we will define the intersection point of the extended straight line CD and the radius OF as point M. So by doing this construction, we actually created quadrilateral BCOM. I write it down here, quadrilateral BCOM. And and inside quadrilateral BCOM we have 1, 2, 3 right angles. I repeat again, inside quadrilateral BCOM we have 1, 2, 3 right angles, and the sum of 3 right angles is 90 times 90 degrees times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DMO. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we'll subtract 270 degrees from this equation, and we get that the missing angle, angle DMO, equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So we found out that the missing angle is a right angle, it is equal to 90 degrees. This angle DMO, is a right angle. So we actually found out that inside quadrilateral BCOM we have 4 right angles. Okay, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral BCOM as a rectangle. Why? Because it has 4 right angles. Okay, quadrilateral BCOM is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle BCOM, side BC must be equal to side OM. BC equals to OM, according to the rule that the opposite sides of a rectangle are equal to each other. But it is given us the question that BC equals to 9 units. So we can write here that BC equals to 9. And from this equation, BC equals to 9 equals to BC equals to OM. We will derive that OM is also equals to 9 units. Okay, so we can write here that OM equals to 9 units. It has given us the question that CD is a straight line. And then we extended the straight line CD by a straight line. In this way we created line segment CM. And when you extend a straight line by a straight line, the result must be a straight line. So the result CM must be a straight line. So I write it down that CM must be a straight line. CM is a straight line. Okay, and we actually have rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have the straight line CD. If you focus on the upper side of the straight line CD at point O, here the sum of the angles must be equal to 180 degrees. That is to say, alpha plus beta, which angles we have on the upper side of the straight line CD at point O. We have angles alpha and beta, and therefore alpha plus beta must be equal to 180 degrees. We can implement rule number 3 in our drawing. Why? Because we know that CM is a straight line. So if we focus on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees according to rule number 3. Which angles we have in this side of CM at point D? We have here 90 degrees, this angle, plus this angle that is actually angle LDM. In total, the sum of those two angles must be equal to 180 degrees. Okay. So here we subtract 90 degrees from this equation and we'll get that the missing angle LDM is equal to 180 degrees minus 90 degrees. It is equal to 90 degrees. Okay, we found out that the missing angle LDM equals to 90 degrees. This angle MDM equals to 90 degrees. Likewise, we know that OF is the radius of the quarter circle that is equal to R. So OF as the radius of the quarter circle must be a straight line. So I can write down that OF is a straight line. And if we focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees according to rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? So here which angles we have at the upper side of the straight line OF at point M. We have this angle that is equal to 90 degrees plus this angle that is actually angle DMF. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. I repeat again, the sum of the angles on the upper side of the straight line OF at point M must be equal to 180 degrees. That is to say 90 degrees plus the size of angle DMF must be equal to 180 degrees. Here we subtract 90 degrees from this equation and we get that the missing angle DMF is equal to 180 degrees minus 90 degrees. It is equal to 90 degrees. It is a right angle. So if I know that this angle is a right angle, it is equal to 90 degrees. In the next step, we will do a construction from point L, from this point. We will draw perpendicular on the radius OF of the quarter circle. So here, this angle equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point L and the radius OF as point N. And here, by doing this construction, we created quadrilateral DLMN. In quadrilateral DLMN, we have 1, 2, 3 right angles. I repeat again, in quadrilateral DLMN, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DLN, this angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so you subtract 270 degrees from this equation and we get that the missing angle DLN is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. It is a right angle. So angle DLN is a right angle. It is equal to 90 degrees. So we actually found out that inside quadrilateral DLMN we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral DLMN as a rectangle. Why? Because it has 4 right angles. Okay, here, repeat again, quadrilateral DLMN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. The opposite sides of rectangle DLMN, they are equal to each other. That is to say, side DL equals to side MN. DL equals to MN. DL equals to MN according to the rule that the opposite sides of rectangle are equal to each other. But it is given as the question that DL equals to 12 units. So here DL equals to 12 units. So we can write down that DL equals to 12. And from this equation 12 equals to DL equals to MN, we will derive that MN is also equals to 12 units. MN equals to 12 units. In the next step, we'll define side DM as edge. Here, DM equals to edge according to our definition. And according to the same rule that the opposite sides of a rectangle are equal to each other, side DL must be equal to side LN. DL equals to MN. Repeat again, according to the same rule, DL equals to MN. But according to our definition, DL equals to H, DM equals to H. So we can write here that, here first of all, DM equals to LF. DM equals to LF. I repeat again, according to the rule that the opposite sides of rectangle are equal to each other, we get that in quadrilateral DLMN, in a rectangle DLMN, side DM must be equal to side LF. DM equals to LF. Here, DM equals to LF. Okay? But according to our definition, DM equals to H. DM equals to H. And from this equation, H equals to DM equals to LF, we will derive that side LF is also equals to H. Side LF equals to H. We found out that side LF equals to H. So here you can see that points N and points F very close to each other. They are not merged, but they are very close to each other. And the length of line segment ON is 9 plus 12, that is 21. And the radius of the quarter circle is defined as OF. So we know that the radius of the quarter circle is OF, and line segment ON equals to 21 units. And because of the fact that point F is very close to point N, we are expecting that the radius of the quarter circle will be a little bit longer than 21 units, because ON equals to 21 units and points N and F are very close to each other. Okay? In the next step, we will join point C and O together by a straight line. Point O is the center of the quarter circle. Point C is the point of the quarter circle itself. This is exactly the definition of a radius. That is to say, CO is the radius of the quarter circle. That is equal to R according to our definition. In the next step, we will implement the Pythagoras theorem on the green right triangle, triangle COM. Okay. Here PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, in triangle COM, the hypotenuse is CO, therefore the square of the hypotenuse will be CO squared and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to OM squared plus CM squared. I'll repeat again. In the right green triangle, triangle COM, according to the Pythagoras theorem, CO squared must be equal to OM squared plus CM squared. Okay. CO equals to R, it is the radius of the quarter circle, therefore CO squared is R squared. And it is equal to OM squared. OM equals to 9. Therefore OM squared is 9 squared, that is 81. Plus CM squared. CM equals to CD plus DM. Read again, CM equals to CD plus DM, that is to say CM equals to CD, that is 16, plus DM, that is 8. So in conclusion, in total, CM equals to 16 plus h, and therefore CM squared will be equal to 16 plus h squared. Here, we found out that according to equation number 1, R squared equals to 81 plus 16 plus h squared. Here we will open the brackets on this side of equation number 1, and we will get that according to equation number 1, R squared equals to 81 plus 16 plus 8 squared equals to 16 squared, that is 256, plus 8 squared plus 2 times 16, that is 32. 32 times 8 is 32h. In conclusion, according to equation number 1, we got that R squared equals to 81 plus 256 plus 8 squared plus 32h. So according to equation number 1, R squared equals to 81 plus 256 is 337 plus h squared plus 32h. So actually, according to equation number 1, we found out that R squared equals to 337 plus h squared plus 32h. In the next step, we will join points O and L together by a straight line. Point O is the center of the quarter circle. Point N is the point of the quarter circle itself. This is exactly the definition of a radius. That is to say, ON is the radius of the quarter circle. That is equal to R according to our definition. In the next step, we will implement the Pythagoras theorem on the right orange triangle, triangle LNO. I'll repeat again, we will implement the Pythagoras theorem on the right orange triangle, triangle LNO. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse here is LO, therefore the square of the hypotenuse is LO square. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to LN square plus ON square. Repeat again, in the right orange triangle, triangle LNO, according to the Pythagoras theorem, LO square must be equal to LN square plus ON square. So, LO equals to R, therefore LO square is R square, and it must be equal to ln square. Ln equals to h, therefore ln square is h square plus on square. On equals to om plus mn. Again, on equals to om plus mn. That is to say, on equals to om, that is 9, plus mn, that is 12. 9 plus 12 is 21. That is to say, on equals to 21. Therefore, on square equals to 21 square. In conclusion, we found out that according to equation number 1, r square equals to h square plus 21 square. 21 square is 441, so I write it down. So in conclusion, we found out that according to equation number 2, r square equals to h square plus 21 square, that is 441. So according to equation number 2, we found out that r square equals to h square plus 441. So we have two different expressions for r square. In the next step, we'll create equation number 3 that states that r square according to equation number 1 must be equal to r square according to equation number 2. Okay? So here, r square according to equation number 1 equals to r square according to equation number 1 equals to 337 plus h square plus 32h, and it must be equal to r square according to equation number 2, that is equal to h square plus 441. So here we have h square on both sides of equation number 1, of equation number 3. So h square will get cancelled. What is left from equation number 3 after we cancel h square? What is left is that in this side of the equation we have 337 plus 32h. In the other side of equation number 3 we have left only with 441. Here we subtract 337 from this equation, equation number 3, and we get that according to equation number 3, 32h equals to 441 minus 337 is 104. So according to equation number 3, we found out that 32h equals to 104. Here we divide this equation number 3 by 32, and we get that h equals to 104 over 32. And 104 over 32 is 3.25 units. So in conclusion, we found out that h equals to 3.25 units. In the next step, we will substitute h by 3.25 units in equation number 2. According to equation number 2, r squared equals to h squared plus 441. That is to say, according to equation number 2, r squared equals to h squared. H is 3.25, therefore h squared will be equal to 3.25 squared, that is 10.5625, plus 441. And 441 plus 10.5625, it is equal to 451.5625. So here we take a root out of this equation, equation number 3, and we get that the radius of the quarter circle that we are looking for, r, it is equal to the square root of 451.5625, that is actually equal to 21.25 units. Okay, actually we found out that the radius of the quarter circle equals to 21.25 units. As I already mentioned before, we are expecting to radius that is a little bit longer than 21, that is the length of ON, and here we indeed found out that the radius is very close in its length to ON, that is 21 units. Actually, the radius is bigger than line segment ON by 0.25 units, because ON equals to 21 and the radius equals to 21.25 units. So here we finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in two different methods. So in the drawing, we have triangle ABC, angle ACB equals to 40 degrees, angle ADC equals to 80 degrees, side AC equals to Y units in its length, side DC equals to X units in its length, side AB equals to X plus Y units in its length. And we are looking for the size of this angle, angle theta, that is actually also angle ABC. Okay, so in the first step, we will do a construction. We will extend side BC in Y units. So here we define this point as point E. So actually here CE equals to Y units according to our construction. In the next step, we join points A and D together by a straight line. So here we created triangle ACE. So I will copy triangle ACE in a new page and we'll analyze triangle ACE. So this is triangle ACE that I copied from the original drawing. Side AC equals to Y units according to what is given as the question, and side CE equals to Y units according to our construction. So here side AC equals to Y and side CE equals to Y. That is to say, those two sides are equal to each other. So I can write down that side AC equals to side CE, they're both equal to Y, therefore they're equal to each other. Okay? So those two sides are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. Okay? So in front of this side, we have this angle that is actually angle CAE. And in front of this side, side AC, we have this angle that is actually angle AEC. So those two angles must be equal to each other because they are located in front of equal sides. So angle CAE equals to angle AEC according to the rule that I mentioned, that in front of equal sides in the triangle there are equal angles. So I actually found out that angle CAE equals to say angle AEC. So if we define angle CAE as alpha, here angle CAE equals to alpha according to our definition. So from this equation, alpha equals to angle CAE equals to angle AEC, we will derive that angle AEC is also equals to alpha. Okay? Angle AEC is also equals to alpha. So I've actually found out that those two angles, they are both equal to alpha. In the next step, I will copy angle ACB that is equal to 40 degrees to this drawing. So this is angle ACB that I copied from the original drawing, and it is equal to 40 degrees according to what is given as the question. Okay. In the next step, I will present to you the exterior angle theorem. So the exterior angle theorem is true in any triangle. So we have here triangle ABC that could be any triangle. This is triangle ABC. In triangle ABC, this angle equals to alpha, this angle equals to beta, and this angle equals to gamma. So actually angles alpha, beta and gamma are located inside triangle ABC, and therefore they are defined as an exterior angles. I write it down. Angles alpha, beta and gamma are defined as an interior angles because they are located inside triangle ABC. While this angle ACD, this angle is defined as an exterior angle. Why? Because it is located outside triangle ABC. So I write it down. Angle ACD, this angle is defined as an exterior angle of triangle ABC because it is located outside triangle ABC. So we define the exterior angle ACD as E. E equals to ACD according to our definition. Okay, so what is the size of the exterior angle E? The size of the exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. I'll repeat again. The size of the exterior angle E, this angle, is equal to the sum of the two interior angles that are not adjacent to it. This angle gamma, is adjacent to angle E, and the two other angles that are not adjacent to it are alpha and beta, and the sum of those two angles, alpha and beta, is alpha plus beta. So in conclusion, we found out that the size of the exterior angle E, it is equal to alpha plus beta. Okay, and this is true in any triangle. The size of the exterior angle equals to the sum of the two interior angles that are not adjacent to it. Okay, in this case, E equals to alpha plus beta. We will implement the exterior angle theorem in our triangle ACE. In our triangle ACE, those two angles that are alpha and alpha, are both equal to alpha, will be defined as an exterior as an interior angles. Okay, so I write it down. The two angles are defined as an interior angles. While this angle ACB, is defined as an exterior angle. I will write it down. Angle ACB is defined as an exterior angle. And according to the exterior angle theorem, the size of the exterior angle ACB, is equal to the sum of the two interior angles that are not adjacent to it. This angle is adjacent to angle ACB, and the two other angles that are not adjacent to it are alpha and alpha, and the sum of those two angles, alpha and alpha, is alpha plus alpha. So in conclusion, we found out that the size of the exterior angle ACB equals to alpha plus alpha, that is 2 alpha. So in conclusion, we found out that the size of the exterior angle ACB is equals to 2 alpha, but according to what is given as the question, angle ACB equals to 40 degrees. Here, angle ACB is equal to 40 degrees according to what is given as the question. So from this long equation, 40 degrees equals to angle ACB equals to alpha plus alpha, that is equal to 2 alpha, we will derive that 40 degrees is equal to 2 alpha. Here we will divide this equation by 2, and we will get that alpha equals to 40 degrees over 2, that is 20 degrees. So I found out that angle alpha equals to 20 degrees. Here alpha equals to 20 degrees. Alpha equals to 20 degrees. So we'll write down the original drawing. Angle CAE, this angle equals to alpha, and angle alpha equals to 20 degrees. And angle AEC is also equals to alpha. This is angle AEC that is equal to alpha, that is equal to 20 degrees according to what we have already found out. So those two angles are equal to 20 degrees. In the next step, we'll focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees, and the sum of those two angles is 80 degrees plus 40 degrees is 120 degrees. So in triangle ADC, we have the sum of two angles is 120 degrees. Therefore, the size of the third angle must be equal to 60 degrees, because 60 degrees plus 120 degrees is 180 degrees. That is the sum of the angles in any triangle, and especially in triangle ADC. So this angle must be equal to 60 degrees. Okay, in the next step I will copy the triangle ADE in the new page, and we will analyze triangle ADE. Okay. Angle DAE equals to 60 degrees plus 20 degrees is 80 degrees. And this angle ADC, it is also equals to 80 degrees according to what is given as the question. What is the size of side DE? Side DE equals to DC plus CE. That is to say, DE equals to DC, that is X, plus CE, that is Y. So in total, DE equals to X plus Y. Okay. So this is triangle ADE that I copied from the original drawing. We found out that D equals to X plus Y. Those two angles, they are both equal to 80 degrees, and therefore they are equal to each other. So we can write down that angle, this angle ADE, is equal to this angle angle DAE, and they are both equal to 80 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal sides. So in front of this angle, we have side AE. And in front of this angle, that's equal also to 80 degrees, we have side DE. And those two sides must be equal to each other because they are located in front of equal angles. That is to say, side AD equals to side DE. Okay? But we have already found out that side DE equals to X plus Y. So I can write down that D equals to X plus Y. And from this equation, AE equals to DE equals to X plus Y, we will derive that side AE is also equals to X plus Y. Okay? This side AE equals to X plus Y. In the next step, I will copy the big triangle ABE in this page, and we'll analyze triangle ABE. angle ABE equals to theta, according to what is given as the question. Side AB equals to x plus y, according to what is given as the question. And we just right now found out that side AE equals to x plus y. Side AE equals to x plus y. Yeah. So this is triangle ABE that I copied from the original drawing. Here, this angle AEB, is equal to 20 degrees according to what is given us, according to what we have already found out, that is actually angle alpha that is equal to 20 degrees. So we can write here that this angle equals to 20 degrees. Again, this is triangle ABE that I copied from the original drawing. Those two sides, they are both equal to x plus y, therefore they are equal to each other. I write it down. Side AB in triangle ABE is equal to side AE. I repeat again, those two sides are both equal to x plus y, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So here, in front of this side, side AE, we have angle theta. While in front of this side, side AB, we have this angle that is equal to 20 degrees. And those two angles that are located in front of equal sides, that is to say side AB and side AE, they must be equal also to each other. So in conclusion, we found out that angle theta equals to 20 degrees. I repeat again, those two angles are located in front of two equal sides, therefore they are also equal to each other. So angle theta equals to 20 degrees. We finished with the first method. In the next step, I present to you the second method. In the second method, we'll focus on triangle ADC. Triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. So we have the sum of two angles in triangle ADC is 120 degrees. Therefore, the size of the third angle must be equal to 60 degrees, because 60 degrees plus 120 degrees is 180 degrees. That is the sum of the angles in any triangle, and especially in triangle ADC. We'll define side AD as A. In the next step, I will present to you the law of sines, and we will implement the law of sines in triangle ADB and triangle ADC. So, what is the law of sines? The law of sines is true in any triangle. So here triangle ABC, this could be any triangle. This is triangle ABC. In triangle ABC, the size of side BC, the length of side BC is equals to A units, and the size of angle BAC, this angle equals to capital A degrees, and we know that the length of side AC is B units, and the size of angle ABC is capital B degrees. And finally, the length of side AB is equal to C units, and the size of angle ACB is equal to capital C degrees. Okay, so in this triangle ABC, that could be any triangle. A over sine A equals to B over sine B, and it is equal to C over sine C. I'll repeat again. In this triangle ABC, A over sine A equals to B over sine B equals to C over sine C. We will implement the law of sines in the green triangle ADC. Okay, in the green triangle ADC, according to the law of sines, we get that DC over sinus 60 degrees, here, DC over sinus 60 degrees equals to AC over sinus 80 degrees and it is equal to AD over sinus 40 degrees. Repeat again. In the green triangle ADC, according to the law of sines, we get that DC over sinus 60 degrees equals to AC over sinus 80 degrees, and it is equal to AD over sinus 40 degrees. Okay. Here DC equals to X, so we'll substitute DC by X. AC equals to Y, therefore we'll substitute AC by Y. And finally, AD equals to A, therefore we'll substitute AD by A. Okay, so this is the expression that we got here. So we have here three expressions that are all equal to each other, 1, 2, 3. Therefore, because of the fact that they are all equal to each other, we will define the value of each of them as k. Therefore, all will be equal to k. Okay, we define the value of each expression as k, therefore they are all equal to k, of course. And then those two expressions are equal to each other, that is to say x over sinus 60 degrees is equal to k, according to this equation. Here we will multiply this equation number 1, by sinus 60 degrees, and we will get it according to equation number 1, x equals to k times sinus 60 degrees. Okay. Those two expressions are also equal to each other for this equation. Therefore, we can write down that y over sinus 80 degrees is equal to k. Here we multiply this equation number 2, by sinus 80 degrees, and we get that according to equation number 2, y equals to k times sinus 80 degrees. Okay. And finally, those two expressions are also equal to each other according to this equation. So we can write down that a over sinus 40 degrees is equal to k. Here we multiply this equation number 3, by sinus 40 degrees, and we get that according to equation number 3, A equals to k times sinus 40 degrees. So we have three expressions for a, x, and y. In the next step, we will find out the size of this angle ADB. BC is one side of triangle ABC, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line BC at point D, the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have on the upper side of BC at point D? We have this angle that is equal to 80 degrees plus this angle that is angle ADB. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. So this angle equals to 80 degrees. Therefore, this angle must be equal to 100 degrees in order to complete the sum of the angles on the upper side of the straight line BC at point D to 180 degrees. This angle must be equal to 100 degrees. So you write down that this angle ADB equals to 100 degrees. Okay, so in the next step, we will implement the law of sines in the orange triangle ABD. Repeat again, we will implement the law of sines in the orange triangle ABD. According to the law of sines, in the orange triangle ABD, we will get that AD over sinus theta equals to AB over sinus 100 degrees. I repeat again. In the orange triangle, triangle ABD, according to the law of sines, AD over sinus theta equals to AB over sinus 100 degrees. Here, AD equals to A, therefore we'll substitute AD by A, and we get that A over sinus theta equals to AB. AB equals to x plus y, so we'll substitute AB by x plus y over sinus 100 degrees. So according to equation number 2, we found out that A over sinus theta equals to x plus y over sinus 100 degrees. But we have already found out the values of A, x and y. So we'll substitute A, x and y by the values that we found for them. Okay, here we have the values of x, the value of y, and the value of A. Okay, so we substitute A, x and y by the values that we found for them, and we'll get that according to equation number 2. Here we know that A equals to k times sinus 40 degrees, so we substitute A by k times sinus 40 degrees over sinus theta, and it is equal to x plus y. Here, as I already mentioned before, x equals to k sinus 60 degrees and y equals to k sinus 80 degrees. Therefore, we substitute x and y by the values that we found for them. So here it is equal to x, and x equals to k times sinus 60 degrees plus y, and y equals to k times sinus 80 degrees, all divided by sinus 100 degrees. Okay, repeat again. We substituted A, x and y by the values that we found for them, and we got this equation number 2. So here we have k on both sides of equation number 2, so k will get cancelled. What is left from equation number 2 after we cancelled k? What is left is that in this side of the equation we have sinus 40 degrees over sinus theta, that is equal to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. So here we will multiply this equation, equation number 2, and we get that according to equation number 2, sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. Okay, so here we divide this equation, equation number 2, by sinus 60 degrees plus sinus 80 degrees, and we will get that according to equation number 2, sinus theta is equal to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Repeat again, sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. We have the first trigonometric identity, that sinus 2a equals to 2 times sinus a times cosine a. Repeat again, the trigonometric identity states that sinus 2a equals to 2 times sine a cosine a. We'll use this trigonometric identity in order to find the value of sinus 40 degrees. Sinus, that is in equation number 2, of course. Sinus 40 degrees equals to sinus 2 times 20 degrees. And according to this trigonometric identity, that sinus 2a equals to 2 sine a cosine a, we get that sinus, according to this trigonometric identity, sinus 2 times 20 degrees will be equal to 2 times sinus 20 degrees times cosine 20 degrees. Okay? So in conclusion, we found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Okay? Later we'll substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees. But we have another trigonometric identity that states that sinus 90 degrees plus theta is equal to cosine theta. And we will use this trigonometric identity for sinus 100 degrees. Sinus 100 degrees equals to sinus 90 degrees plus 10 degrees, of course. And sinus 90 degrees plus 10 degrees, according to this trigonometric identity, that sinus 90 degrees plus theta equals to cosine theta will be equal to cosine 10 degrees. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees. So therefore, we will substitute sinus 100 degrees by cosine 10 degrees in equation number 2 here, and we will also substitute sinus 40 degrees in this equation number 2 by 2 times sinus 20 degrees times cosine 20 degrees. We will do it now, and we will get that according to equation number 2, sinus theta, according to equation number 2, sinus theta equals to sinus 40 degrees, but sinus 40 degrees is 2 times sinus 20 degrees times cosine 20 degrees. And according to equation number 2, we have to multiply sinus 40 degrees by sinus 100 degrees, but sinus 100 degrees equals to cosine 10 degrees, so we substitute sinus 100 degrees in equation number 2 by cosine 10 degrees, and all divided by sinus 80 degrees over plus sinus 60 degrees. Okay. So we have another trigonometric identity that we will use it for the value of sinus 80 degrees plus sinus 60 degrees. According to this trigonometric identity, sinus D plus sinus C is equal to sinus D plus C over 2 2 times sinus d plus c over 2 times cosine d minus c over 2. Repeat again. We have the trigonometric identity that states that sinus d plus sinus c equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. We'll use this trigonometric identity to find the value of sinus 80 degrees plus sinus 60 degrees. According to this trigonometric identity, we'll get that sinus 80 degrees plus sinus 60 degrees will be equal to 2 times sinus d plus c over 2. D is 80, c is 60, therefore d plus c is 80 plus 60, that is 140, and 140 over 2 is 70 degrees, times cosine d minus c over 2. D is 80, c is 60, therefore 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we can substitute sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees in equation number 2. We'll do it now and we'll get that according to equation number 2, sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees, all divided by sinus 80 degrees plus sinus 60 degrees, but we just right now found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we substitute sinus 80 degrees plus sinus 60 degrees in this equation, equation number 2, by 2 times sinus 70 degrees times cosine 10 degrees. So here we have cosine 10 degrees in the numerator and we have cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. Likewise, we have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So what is left from equation number 2 after we cancel those 2 expressions? What is left? Actually, we have only left with sinus theta, this of the equation, that is equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. Okay, that's all. That's what's left from equation number 2. We cancel the 2 expressions. We have the last trigonometric identity that states that sinus 90 degrees minus theta equals to cosine theta. Okay, we'll use this trigonometric identity for the value of sinus 70 degrees. Sinus 70 degrees is equal to sinus 90 degrees minus 20 degrees, and sinus 90 degrees minus 20 degrees, according to this equation that sinus 90, according to this trigonometric identity that sinus 90 degrees minus theta equals to cosine theta, will be equal to cosine 20 degrees. Again, sinus 90 degrees minus 20 degrees equals to cosine 20 degrees according to this trigonometric identity. So in conclusion, we found out that sinus 70 degrees it is equal to cosine 20 degrees. Therefore, we can substitute sinus 70 degrees by cosine 20 degrees in this equation, equation number 2. We'll do it now and we'll get that according to equation number 2. Sinus theta equals to sinus 20 degrees times cosine 20 degrees, all divided by sine of 70 degrees, but we have already found out that sine of 70 degrees equals to cosine 20 degrees, therefore we substitute sine of 70 degrees here in this equation by cosine 20 degrees. So here we have cosine 20 degrees in the numerator and we have cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled and we're left only with sinus theta that is equal to sinus 20 degrees. And we have the trigonometric identity that if sinus alpha equals to sinus beta, it means that alpha equals to beta. So if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So in the second method, we also found out that the size of angle theta is equal to 20 degrees. So we finished with the second method. In the next step, I will summarize the lecture. We'll start with the first question, of course. In the drawing, we have a quarter circle. Side BC equals to 9 units, side CD equals to 16 units, side DL equals to 12 units. This angle OBC equals to 90 degrees, this angle BCD equals to 90 degrees, and this angle also angle CDL equals to 90 degrees. And our mission is to find out the radius of this quarter circle. So because of the fact that this is a quarter circle, it means that point O is the center of the quarter circle. This angle equals to 90 degrees, and side AO equals to side BA, to side OF, and both sides are the radii of this quarter circle. We define the radius of the quarter circle as R, therefore AO will be equal to R, and OF will be also equal to R. They are both the radii of the quarter circle. Okay, in the next step, we extended the straight line CD by a straight line, and we defined the touching point of the extended CD and OF as M. So here we created quadrilateral BCOM. Inside quadrilateral BCOM, we have 1, 2, 3 right angles, and the sum of 3 right angles is 270 degrees. Plus the size of the fourth angle, that is actually angle DMO. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and found out that the missing angle, angle DMO, equals to 360 degrees minus 90 degrees, it is equal to 90 degrees. So this angle, angle DMO, equals to 90 degrees. So actually found out that inside quadrilateral BCOM we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral BCOM as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. That is to say, BC must be equal to OM. In rectangle BCOM, BC must be equal to OM. But according to what is given as the equation, BC equals to 9 units. Okay, BC equals to 9 units, therefore we can write down that BC equals to 9, and from this equation 9 equals to BC equals to OM, we will derive that OM is also equal to 9 units. Here OM equals to 9 units. Okay, then here we know is given as the equation that CD is a straight line, and when we extended the straight line CD by a straight line, the result is CM. When you extend the straight line by a straight line, the result must be a straight line. Therefore, CM must be a straight line. So we can write down that CM is a straight line, and we have the rule number 3 that and the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at this side of CM at point D? We have this angle that is equal to 90 degrees plus this angle that is actually angle LDM. In total, the sum of those two angles must be equal to 180 degrees. We subtracted 90 degrees from this equation and found out that the missing angle LDM equals to 90 degrees. This angle equals to 90 degrees. Likewise, we know that OF is the radius of the quarter circle, therefore here OF is the radius of the quarter circle, therefore it is absolutely a straight line. So we can find out that OF is a straight line. So if we focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have on the upper side of OF at point M? We have this angle that is equal to 90 degrees plus angle DMF. In total, the sum of those two angles must be equal to 180 degrees. Here we have 90 degrees plus the size of angle DMF. In total, they must be equal to 180 degrees. We subtracted 90 degrees from this equation and found out that the missing angle DMF equals to 180 degrees minus 90 degrees. It is 90 degrees. So this angle DMF equals to 90 degrees. Then we did the construction from point N. We do perpendicular on OF. Repeat again, from point N we do perpendicular on OF. So this angle equals to 90 degrees according to our construction. So here we created quadrilateral DLMF. Inside quadrilateral DLMF we have 1, 2 free right angles. Again, inside quadrilateral DLMF we have 1, 2 free right angles. And the sum of free right angles is 270 degrees plus the size of the fourth angle, that is angle DLN. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and found out the missing angle, that the missing angle DLN equals to 360 degrees minus 270 degrees. It is equal to 90 degrees. So this angle, it is a right angle, it is equal to 90 degrees. So we actually found out that inside quadrilateral DLMN we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle of not a square. So we relate to quadrilateral DLMN as a rectangle. Why? Because it has 4 right angles. And we also know that the opposite sides of a rectangle are equal to each other. So that is to say, the side DL must be equal to side MN. DL equals to MN. But according to what is given as the equation, DL equals to 12 units. So you can write down that DL equals to 12 units, and from this equation 12 equals to DL equals to MN, we will derive that MN equals to 12 units. Okay, MN equals to 12 units. Then we define side DM as edge. Side DM equals to edge according to our definition. According to the same rule that the opposite sides of a rectangle are equal to each other, we get that DM equals to LF. Here, DM equals to LF. But according to our definition, DM equals to edge. So from this equation, edge equals to DM equals to LF, we will derive that LF is also equals to edge. Here, LF is also equals to edge. Then we join point C and O together by a straight line. Point O is the center of the quarter circle. Point C is the point of the quarter circle itself. Therefore, CO is the radius of a quarter circle. This quarter, therefore, CO is the radius of the quarter circle that is equal to R according to our definition. Then we implemented the Pythagoras theorem on the green triangle, triangle COM. According to the Pythagoras theorem, CO square equals to OM square plus CM square. Repeat again. In triangle COM, according to the Pythagoras theorem, CO square equals to OM square plus CM square. CO equals to R, therefore CO square is R square plus OM. OM equals to 9, therefore OM square. OM equals to 9, therefore OM square is 9 square, that is 81. And here CM equals to CD plus DM, that is to say CM equals to CD, that is 16, plus DM, that is H. In total, CM equals to 16 plus H, therefore CM squared equals to 16 plus H squared. So in conclusion, found out that R squared equals to 81 plus 16 plus H squared. We open the brackets on this side of equation number 1 and found out that R squared equals to 81 plus 16 plus H squared equals to 16 squared, that is 256, plus H squared plus 2 times 16, that is 32, times H is 32H. So in conclusion, found out that according to equation number 1, R squared equals to 81 plus 256 plus H squared plus 32H. 81 plus 256 is 337. So in conclusion, found out that according to equation number 1, R squared equals to 337 plus H squared plus 32H. Then we joined points O and L together by straight line. Point O is the center of the quarter circle. Point L is the point of the quarter circle itself. Therefore, OL is the radius of the quarter circle, that is equal to R. Then we implemented the Pythagoras theorem on the orange triangle, triangle OLN. According to the Pythagoras theorem, in the orange triangle, triangle OLN, OL square equals to LN square plus NO square. Repeat again. In the orange triangle, triangle OLN, NO square equals to NN square plus NO square. NO equals to R, therefore NO square equals to R square. LN equals to H, therefore NN square is H square. And what is the size of ON? ON equals to OM plus MN. That is to say, ON equals to OM, that is 9, plus OMN, that is 12. And 9 plus 12 is 21. So in conclusion, we found out that ON equals to 21, therefore ON square is 21 square. So in conclusion, we found out that according to equation number 2, R square equals to H square plus 21 square. 21 square is 441, so in conclusion, we found out that R square equals to H square plus 441. So we have two different expressions for R square. Therefore, we created equation number 3 that states that R square according to equation number 1 must be equal to R square according to equation number 2. R square according to equation number 1 is 337 plus H square plus 32H, and it must be equal to R square according to equation number 2, that is H square plus 441. Here we have H square on both sides of equation number 3. Therefore, H square will get cancelled. What is left from equation number 3 after we cancelled H square? What is left is that in this side of the equation we have 337 plus 32H. In the other side of the equation we have 441. So here we have 337 plus 32H equals to 441. We subtracted 337 from this equation, equation number 3, and found out that 32H equals to 441 minus 437, that is 104. Here, so 32H equals to 104. We divided this equation, equation number 3, by 32, and found out that H equals to 104 over 32. 104 over 32 is 3.25. So we found out that H equals to 3.25. Then we substituted H in equation number 2 by 3.25. According to equation number 2, R square equals to H square plus 441. Plus 441. So according to equation number 2, R square equals to H square. H is 3.25, therefore H square is 3.25 square. That is actually 10.5625. So actually, in conclusion, found out that R square according to equation number 2 equals to 10.5625 plus 441. And 441 plus 10.5625 is 451.5625, and it is equal to R square according to equation number 3. Here we took a root out of this equation, equation number 3, and found out that the radius of the quarter circle that we are looking for, it is equal to 21.25 units. Here, and it is very close to, it is a little bit, it is longer by 0.25 from ON, that is equal to 21 units. Okay, we finished with the first question, then I presented to you the second question. we have here triangle ABC, side AB equals to x plus y units, side AC equals to y units, side DC equals to x units, this angle equals to 40 degrees, this angle ADC equals to 80 degrees, and our mission is to find out the size of this angle theta. So in the first method we did the construction, we extended side BC by y units, that is to say C equals to y units according to our construction. Then we joined points A and D together. In this way we created triangle AEC, so I copied triangle AEC in the new page, we analyze triangle ACE. So this is triangle ACE that I copied from the original drawing. AC equals to y according to what is given as the question, and C equals to y according to our construction. So those two sides, they are both equal to y, therefore they are equal to each other. That is to say AC equals to CE equals to y, and therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of side AC we have angle AEC. In front of this side CE we have angle EAC. And those two angles must be equal to each other because of the fact that they are located in front of equal sides. That is to say angle AEC equals to angle CAE. So if we define this angle, as alpha, then we will get from this equation alpha equals to CAE equals to AEC. From this equation we will derive that this angle is also equals to alpha. So we found out that those two angles are both equal to alpha, therefore they are equal to each other. Then I copied angle ACB that is equal to 40 degrees from the original drawing. And then I presented to you the exterior angle theorem. The exterior angle theorem is true in any triangle. So here we have triangle ABC. This angle equals to alpha, this angle equals to beta, this angle equals to gamma. So here alpha, beta and gamma are defined as interior angles because they are located inside triangle ABC. While this angle ACB, that is angle ACD, that is located outside triangle ABC, it is defined as an exterior angle. So this angle that is defined as E is defined as an exterior angle. And what is the size of the exterior angle ACD that is equal to E? According to the exterior angle theorem, it is equal to the sum of the two interior angles that are not adjacent to it. Here angle gamma is adjacent to angle E, and the other two angles that are not adjacent to it are alpha and beta. And the sum of those two angles, alpha and beta, is alpha plus beta. Therefore the size of this angle E is equal to alpha plus beta. That is the sum of the two interior angles that are not adjacent to it. We implemented the exterior angle theorem in our triangle AC. Here, those two angles are located inside triangle ACE, therefore they are defined as interior angles, while this angle ACB that is located outside triangle ACE is defined as an exterior angle. So the size of the exterior angle ACB according to the exterior angle theorem, it will be equal to the sum of the two interior angles that are not adjacent to it. This angle is adjacent to it, to angle ACB, and the other two interior angles that are not adjacent to it are those two angles, alpha and alpha. And the sum of those two angles is alpha plus alpha. So in conclusion, we found out that the size of the exterior angle ACB, this angle, it is equal to alpha plus alpha, that is 2 alpha. So angle ACB equals to 2 alpha from one side, but from the other side, angle ACB equals to 40 degrees according to what is given as the equation. So here from this long equation, 40 degrees equals to angle ACB equals to alpha plus alpha equals to 2 alpha. We will derive that 40 degrees equals to 2 alpha. Therefore, we divided this equation by 2 and we got that angle alpha equals to 20 degrees. Here angle alpha equals to 20 degrees, and here also angle alpha equals to 20 degrees. So we can write down here, this is angle alpha and it is equal to 20 degrees, and this is also angle alpha that is also equals to 20 degrees. Then I copied triangle ADE in the new page and we analyze triangle ADE. this is triangle ADE that I copied from the original drawing. This angle DAE equals to 60 degrees plus 20 degrees, that is 80 degrees. And this angle equals to 80 degrees according to what is given as the question. And what is the length of side DE? DE equals to DC plus CE. That is to say, DE equals to DC, that is X, plus CE, that is Y. So in total, DE equals to X plus Y. Here, DE equals to X plus Y. So in this triangle ADE, those two angles are equal to each other, therefore they are equal to each other. That is to say, angle ADE equals to angle DAE, and they are both equal to 80 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal sides. So in front of this angle, we have side DE, and in front of this angle, we have side AE, and according to the rule that I mentioned, those two sides that are located in front of equal angles must be also equal to each other. That is to say, side AE must be equal to side DE. But we have already found out that DE equals to X plus Y, so we can write here that DE equals to X plus Y. And from this equation, A equals to D equals to X plus Y, we will derive that AE is also equals to X plus Y. Here, AE is also equals to X plus Y. Then I copied triangle ABE from the original drawing and analyzed triangle ABE. Side AB equals to X plus Y according to what is given as the question. This angle is angle theta according to what is given as the question. We just right now found out that A equals to X plus Y. This angle equals to 20 degrees according to what we have already found out. So here in triangle ABE, both those two sides are equal to each other, therefore both those two sides are equal to X plus Y, therefore they are equal to each other. That is to say, side AB equals to side AE equals to X plus Y. And we have the rule that in front of equal sides in the triangle, there are equal angles. In front of side AB, we have angle that is equal to 20 degrees, and in front of side AE, we have this angle that is equal to theta, and those two angles that are located in front of equal sides must be also equal to each other. That is to say, angle theta equals to 20 degrees. We finished with the first method, and I presented to you the second method. In the second method, we focused on triangle ADC. In triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees, and the sum of those two angles is 80 degrees plus 40 degrees is 120 degrees. So if the sum of two angles in a triangle is 120 degrees, it means that the third angle must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees is 180 degrees. That is the sum of the angles in any triangle, and especially in triangle ADC. So this angle equals to 60 degrees. Then we define side AD as A, and then I presented to you the law of sines. The law of sines is true in any triangle, so this is triangle ABC that could be any triangle. Side AB equals to C units, side AC equals to B units, side BC equals to A units. This angle equals to capital A degrees, this angle equals to capital B degrees, and this angle ACB equals to C capital C degrees in its size. According to the law of sines, we get that A over sine A equals to B over sine B equals to C over sine C. Okay? Then we implemented the law of sines in the green triangle, triangle ADC. According to the law of sines, we get that DC over sinus 60 degrees equals to AC over sinus 80 degrees, and it is equal to AD over sinus 40 degrees. ADC equals to X, so we substitute DC by X. AC equals to Y, so we substitute AC by Y, and AD equals to A, so we substitute AD by Y, and we got this expression. So we have three expressions that are all equal to each other, therefore we define them as K, and then we derived the first equation from this long equation. Those two expressions are equal to each other. That is to say, X over sinus 60 degrees equals to K. We multiplied this equation number 1 by sinus 60 degrees, and found out that X equals to K times sinus 60 degrees. Then we derive the second equation from this normal equation. Those two expressions are also equal to each other. That is to say, y over sinus 80 degrees equals to k. We multiplied this equation number 2 by sinus 80 degrees and found out that y equals to k times sinus 80 degrees. And finally, those two expressions are also equal to each other. That is to say, a over sinus 40 degrees equals to k. Then we multiplied this equation number 3 by sinus 40 degrees and found out that according to equation number 3, a equals to k times sinus 40 degrees. Okay, then we found the sides of this angle ADB. BC is one side of triangle ABC, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line BC at point D, the sum of the angles must be equal to 180 degrees according to rule number 3. Which angles we have at the upper side of BC at point D? We have this angle that is equal to 80 degrees plus this angle ADB, that is, we don't know what is the size of it. So the sum of those two angles in total must be equal to 180 degrees. But if this angle equals to 80 degrees, this angle must be equal to 100 degrees. In order to complete the sum of the angles in the upper side of the straight line BC at point D to 180 degrees, this angle must be equal to 100 degrees. Because 100 degrees plus 80 degrees is 180 degrees, and that is the sum of the angles on the upper side of the straight line BC at point D. So this angle must be equal to 100 degrees. Then we implemented the law of sines in the orange triangle ABD. According to the law of sines in the orange triangle ABD, we will get that AD over sinus theta equals to AB over sinus 100 degrees. First again, in the orange triangle ABD, according to the law of sines, AD over sinus theta equals to AB over sinus 100 degrees. And repeat again, AD over sinus theta equals to AB over sinus 100 degrees. AD equals to A, we substitute AD by A. AB equals to x plus y, we substitute AB by x plus y, and we got this equation A over sinus theta equals to x plus y over sinus 100 degrees. Then we substitute A by k times sinus 40 degrees, we substitute x by k times 60 degrees, times sinus 60 degrees, and substitute y by k times sinus 80 degrees, and we got this expression. Here we have k on both sides of the equation, so k will get cancelled. What is left from equation number 2 after we cancel k? What is left is that k that sinus 40 degrees over sinus theta equals to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Then of course multiply this equation number 2, and we found out that sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. Here we divided this equation number 2 by sinus 60 degrees plus sinus 80 degrees, and found out that according to equation number 2, sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Then I presented to you the second and the first trigonometric identity, that sinus 2a equals to 2 sine a cosine a. And we have use this trigonometric identity for the value of sinus 40 degrees. Sinus 40 degrees is sinus 2 times 20 degrees, and according to this trigonometric identity, sinus 2 times 20 degrees will be equal to 2 times sinus 20 degrees times cosine 20 degrees. In conclusion, we found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. And then I presented to you the second trigonometric identity that states that sinus 90 degrees plus theta equals to cosine theta. We use this trigonometric identity for the value of sinus 100 degrees. Sinus 100 degrees equals to sinus 90 degrees plus 10 degrees, of course. And sinus 90 degrees plus 10 degrees equals to cosine 10 degrees. According to this trigonometric identity, that sinus 90 degrees plus theta equals to cosine theta. Therefore, sinus 90 degrees plus 10 degrees will be equal to cosine 10 degrees. So in conclusion, found out that sinus 100 degrees equals to cosine 10 degrees. So we substituted sinus 100 degrees in equation number 2 by cosine 10 degrees. And we substituted sinus 40 degrees in this equation number 2 by 2 times sinus 20 degrees times cosine 10 degrees. After we substituted those two expressions in equation number 2, we found out that according to equation number 2, sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees, that is actually the value of sinus 40 degrees, and times cosine 10 degrees, that is the value of sine 100 degrees. All divided by sinus 80 degrees plus sinus 60 degrees. Then I presented to you the trigonometric identity that sinus d plus sinus c equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. We use this trigonometric identity for the value of sinus 80 degrees plus sinus 60 degrees that is inside equation number 2. According to this trigonometric identity, sinus 80 degrees plus sinus 60 degrees will be equal to 2 times sinus d plus c over 2. D is 80, c is 60. 80 plus 60 is 140, and 140 over 2 is 70. Times cosine d minus c over 2. D is 80, c is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we substituted sinus 80 degrees plus sinus 60 degrees by 2 times sinus 80 degrees, 2 times sinus 70 degrees times cosine 10 degrees in equation number 2, and we got this expression that sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees, and here we substituted sinus 80 degrees by plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. So here we have cosine 10 degrees in the numerator, and we have cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. Likewise, we have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. What is left from equation number 2 after we cancel those two expressions? What is left is actually in this side of the equation we have sinus theta. In the other side of the equation we have sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. Then we have the last trigonometric identity that sinus 90 degrees minus theta equals to cosine theta. We use this trigonometric identity for the value of sinus 70 degrees. Sinus 70 degrees equals of course to sinus 90 degrees minus 20 degrees, and the value of sinus 90 degrees minus 20 degrees, it is equal to cosine 20 degrees according to the trigonometric identity that sinus 90 degrees minus theta equals to cosine theta. Therefore, sinus 90 degrees minus 20 degrees will be equal to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we can substitute sinus 70 degrees by cosine 20 degrees in equation number 2. We did it, and we got that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over cosine 20 degrees. We have cosine 20 degrees in the numerator, and we have cosine 20 degrees in the denominator. So cosine 20 degrees will get cancelled, and we left only with sinus theta that is equal to sinus 20 degrees according to equation number 2. And we know that if sinus alpha equals to sinus beta, it means that alpha equals to beta. So if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So in both methods, we found out that the size of this angle theta in triangle ABC is equal to 20 degrees. Okay, thank you very much.